Hi to everyone, welcome to this video. I'm here to share with you my advice for preparing the exam of data mining and text mining. I am Matteo and I followed entirely the course. Something briefly about me: I did my bachelor here at Polyme. These are the courses I followed, and here is my final mark in data mining, 27. Then my suggestions are based basically on the analysis of previous exams, especially the 5 most recent exams, also on the slides of the lectures, on the notebooks, and of course on my personal opinion. The latest exams, in the very latest exam, there were the first exercise was about hierarchical clustering and compute the 2 indexes. Then we have the a priori, and we have the 2 generate rules, then analysis about silhouette analysis, but we have to comment on it. Then one exercise about bag of words and term frequency inverse document frequency similarity, and one about the trees, and the last one that is for the loud is a comparison between 2 clustering algorithms. Let's move on. The overview of the exam structure: I grouped the type of exercise into 3 groups. One is made of mechanical exercise, the second one is about describing algorithms, and the third one involves reasoning on data science topics in general and comment stuff. You should already know that each exam is composed of about 6 exercises, most of them worth 6 points, while the last one is only 3. Let's start. The mechanical part. One frequent exercise asked is about the frequent item set and rules. These were the previous year's questions, and some common exercise are about the construction of the FP3s. So you need to know the 3 algorithms: the a priori, the FP3s, and ECLAT. They are all 3 explained in the slides, and then you have to know also the rules generation. And for this part, the formulas you need to know are these, and we have the support, the confidence, the lift, and the leverage are the most difficult to remember, but I provided you also a cheat sheet with all these formulas that you can download. Another type of mechanical exercise that is frequent is the clustering one, in which you have to apply the hierarchical clustering most of the times, but sometimes also k-means was asked. And for the clustering, for the hierarchical clustering, we have 2 types of exercise. In one, you have the squares on the sheet, and you need to plot every point, as it was the case of the last exam. And in another case, instead, you are given with a table, the similarity table, and you have to do your calculation on it. And I found easier to rewrite the similarity table, just not to get confused at each step, I mean. So the main formulas for this part are about distance. The most difficult one may be the cosine, and one thing to highlight is that in the last exam there were a question about computing the cosine similarity, and almost every one of us computed the distance, the cosine distance, because it was the only one on the slides. And so, but the similarity is without the arccosine, so you have to remember this. Then the other has only to be studied, I think. Let's go on. We have the internal measures that are within cluster sum of square, between cluster sum of square, and the silhouette coefficient and the aggregation of it, as you can see in the bottom right. Then another exercise, very frequent, is the decision tree, and you have to compute the split, and sometimes you have also to draw the decision tree. In the last exam, we have to decide for the best attributes to split. So we have to compute the gain, the info gain for each attribute. There are two, as you know, purity measures that are the entropy and the Gini index, and here you can see summarized the process. One thing to notice is that the logarithms is usually the logarithm of 2, but if you have 3 classes and you want to have an entropy between 0 and 1, you have to use the logarithm of 3, as it was the case of the last exam, but it's not mandatory. You can use a logarithm of 2 everywhere, in every case, and you simply won't have an entropy below 1, but no problem, because the professor said it is the same. Another mechanical exercise is the one with the naive bias, and especially the correction with the Laplace estimator. You can have an example on the slides in this part about naive bias. And the most important formulas are, as I said, the Laplace estimator that add 1 at the numerator and d at the denominator. D is the different number of unique values of that attributes. So if in that attribute you have 3 different type of unique values, you have to add 1 at the numerator and 3 at the denominator. The M estimate is the formula for the text classifier, and with the naive bias as well. Another exercise is about computing indices and read the outputs or compute performance of KNN, something like that. These are the most important formulas you have to remember, and the precision and recall diagram is for sure important, but also the other one, that is the ROC curve, that is frequently asked during the reasoning question about data science in general. And you have to remember how to compute a false positive rate and true positive rate. Then the text mining formulas are this one, and the first is the most important, and you have for sure to know it. Remember that you have to use the logarithm of 10 here, while in the other two are important to know, but are a special adaptation, and maybe we are not required to know them, but it's better to study also them. Then the second type of exercise I decided to group is the description, the formal description of an algorithm. And in these the exams of the last year, there were 3 requests about writing pseudocode, and they were about ADA boost, gradient boosting, and random forest. You can find, I think that the most clear pseudo algorithms on the slide is this one about ADA boost M1. So I personally studied this version. Then we have gradient boosting. We have to distinguish between the train and test, because usually the request of the exam distinguish between the train method and the predict method. So you have to study both of them. Let's go on. We have also question about description, general description of the algorithms. In one case, there was a word-to-back. In another case, singular value decomposition. You can find both in the, I think, text text pack of slides. Maybe a singular value decomposition in one of the last pack, but done by Loyacono as well. Theoretical topics, they ask the difference between descriptive, predictive, and prescriptive, and also between completeness and optimization. These are the answer to this question are present in the first or second slides of the course, the very first, and you can find them easily. I suggest you to study also the examples. About the comment, this is the third type of exercise, and it's about commenting. For the preprocessing, we find I found this type of questions. You have to describe the preprocessing steps in general. Maybe in some cases you have also to provide exploration technique, something like that. I will go through my personal choices of preprocessing steps, and they are not guaranteed to be correct, completely correct, but it's my point of view. You can comment on it and use the comments to let me know if you don't agree with something. For me, the general preprocessing steps are, for the first one is eliminate outliers, then log transform or skewed distribution, and this happens, distribution is skewed if mean and median are distant. Then I use one hot encoding for maybe, for example, ID sensors, because we don't need to have an ordinal in order between ID sensor, but we are only interested maybe in the specific sensor, so one hot encode is okay, especially if we want to use XGBoost. Then discretization, we can use the 3-4-5 rules, or unsupervised. For unsupervised we can use clustering, or if we want supervised we can use decision tree. But you find all this stuff in the discretization part on the slides. Then you can also handle hierarchies and decide for the best hierarchy for your problem. An example is a small village, province, district, nation, that kind of hierarchies. Then feature selection. For feature selection we have a lasso that sets automatically some weights to 0, so eliminates some feature basically. Random forest has a feature importance characteristic and the ranking also. We can also run the correlation analysis to see if we have two highly correlated input. We can decide to drop one of them. Then also, as I said, manage hierarchies. If we have the entire hierarchies, we can decide only to keep one, remove redundant attributes, and also irrelevant one, as the matricula of the students for predicting his income, for example. For data exploration, we have to distinguish between nominal attributes. Would go for with a bar plot and summary statistics, while for numerical, a box plot can be good. Also histogram with this plot. This plot is a function of Seaborn, a Python library, with KDE is a kernel density estimator, and it's a parameter to show the probability density function on the histogram. But not always the professor likes it, so you can avoid mentioning it. Then outlier analysis, we can do it with the box plot, with the point and jitter, just to see where a point falls outside a certain percentile, so to drop it. Also scatter plot can be good. You can also use winsoring or trimmering if needed. Then best feature for classification. Okay. If you want to decide which is the best feature that separates between two classes, we can use pair plot. Verplot is another Seaborn function that plot every couple of attributes together in a scatter plot, and you can see clearly if there are two groups separated, and you can use those two features for separating and classify your samples. Missing values. One thing that emerged from the slides is that we don't have to delete if the attributes the values are not missing at random, but we have to handle them carefully, maybe with an expert of the field that knows how to handle them. Imputation only if they are missing completely at random or missing at random. Okay. Then how to impute. For numerical we can use regression or mean, regression with other attributes, or use the mean but is sensible to outlier, or median that is less sensible. For categorical we can use classification like logistic regression if we want to use the other attributes, or the mode if we want to stay standard, let's say. Then we can also delete the stuff. Okay, as we said before, the heat map or correlation analysis can be useful to see if two attributes has a high correlation. For example, if we have 3 columns, one for the ID sensor and one for the latitude and longitude of the sensor. If the sensor is stationary, we can say that doesn't move, like for the traffic light. The 3 columns are redundant, we need only one because they carry the same information. Preprocessing steps for corpus of text. The first things I would do is a dictionary for count the word in all the corpus, but it's not mentioned anywhere, it's just rational things to do. And the tokenization using stop words. Eliminate stop words, and also stemming, that is aggregating stuff that has the same prefix, like computer, computing, stuff like that. Dimensionality reduction, based on the latent semantic indexing that is realized with SVD, and then computer representation vector space model, that is also known as bag of words. For time series, as you know, we have also done stuff about it. The first things that Lo Iacono did was setting the date time index. So decide for one column with the date and setting the index, and then you decide sampling. If we have data at different time interval, we can decide to sample everything at every day or every 15 minutes, and we have to decide for the policy, fill forward or fill backward. Then we have also then the next step is an autocorrelation analysis and a partial autocorrelation analysis. They are both done to decide the best order of your model. Then you can run also the key-Fuller test to check if it's a random walk, and then use also a nice function of the package in Python that is the trend as a series with seasonal decompose. Seasonal decompose is the name of the function, and the function is decomposing the trend, the seasonality, and the residual. And we work on the residual. Then the dimensionality reduction techniques are PCA and SVD. PCA works only with numerical, while SVD is good for lots of attributes like text. Then in some questions they ask also for enriching a dataset, and some smart thing I thought was if we have a city, we can use the average income of that city if it's useful, or if we have a column with the geospatial data like time series, we can enrich with weather condition. Another question is about a comment on the code, and okay, these are some examples. Other examples are comparing stuff, and it's especially used in the last question that is visible from the plus on my slides. The question with plus are those that are for the lode, that worth only 3 points, and the one in red is the one they asked in the last exam. And one suggestion for the last question, how to answer to it, as I saw from the last very last exam, and the professor doesn't want a long explanation of stuff, but wants a concise answer to what he asked to you. So in this case, they asked, we have a massive data set, we are using k-means, and our boss asked us, the k-means works actually, and the boss asked us if we have to switch to mean shift clustering, and the answer is no, and because the complexity is too much for a massive data set. So if you only do a comparison, but you don't answer to this question, that is, would you switch or not? If you don't answer, you won't get the 3 points, but only 1. So you have to stay focused on what he asked you and not write what he didn't ask you. As it was my case, because I brought 2 pages of stuff by comparing the 2 algorithms, but I didn't came up with an answer because actually there was not a question mark at the end of that sentence, but there was other 2 sentences that with the question marks that were which are the pros and cons of these 2 methods, question mark. So I focused on that part of the text of the entire exercise, and I didn't answer the previous sentence that didn't have a question mark. So please be careful to what's written in the text. Then explainability. In general, decision tree is good to explain, one single decision tree, because we can derive rules that are human readable. K-means has a natural definition of central, so it's good to explain, it's easy to explain. All clustering algorithms with globular shape in general, because we can compute the centroid afterwards. Also, associative rules can be difficult to explain because we can end up with rules that are not easy to explain, like this, for example. And the worst algorithms to explain are the ensemble one, that are random forest, bagging, and boosting, for example. How to explain the black box? We have studied 3 types of ways of explaining it. We can drop a feature at a time and see the drop of performance, and or in alternative we can use the permutation importance, in which we permute an attribute and we see also the drop of performance, and also in this case. And then a partial dependence plot is another way, and it has to be studied from the notebook, but here you can see an example. And let's move to the notebook. I categorized all the notebook. As you can see, these are the folders you can download from the BIP website, and for each folder I wrote how many notebooks are there in it, and so you can have a measure of how many notebooks you have to run. They are quite a lot, I would say. And here at the right I have summarized some of them, not everything, but for example, as you can see in this notebook, they talk about a priori, eclat, and plot based on the lift. As you can see, there are some nice stuff. And okay, in this this is nice, and you can see the rock, precision record curve. I would recommend it, but mainly you have to look at all of them. Here you can see the elbow analysis, some internal measures, some external benchmark, also the snake plot. It's a good keyword to use in the answers because the professor puts a lot of emphasis on snake plots. They are quite good to explain stuff. And also KNN, difference between uniform parameter and distance. Some other stuff. Then we have the wrapper of cross-validation. We have also the difference between the clustering of the k-means that is good for globular, but not for us anisotropically. Okay, silhouette analysis is good if 1, is bad if -1, generally speaking, but you have also to analyze the shape of the silhouette coefficient. Feature selection methods, we have the PCA. 4dB scan is good for non-globular shapes. Then we can visualize decision trees. Well, you can have a look. Then for time series, I suggest you to understand the difference between autocorrelation and partial autocorrelation. You can find something here, and that's pretty everything. Okay, thank you for the attention. I have finished. If you have any question, you can ask in the comments. I would try to answer. And that's all. Good luck for your exam.